Hello and welcome back to Analytical Instrumentation. Today we will learn about sampling methods and techniques of IR spectroscopy. Any form of sample, whether it is solid, liquid or gas, it can be analyzed using IR spectroscopy. The sample must possess a dipole moment. For IR opaque materials, the samples must be dissolved in a transparent matrix to obtain the spectra. Now, what is dipole moment? In covalently bonded compounds, the bond is formed due to the sharing of electron, but due to presence of electronegative elements, they possess slightly negative charge and the electropositive element will possess slightly positive charge. This is known as dipole moment. So sampling of solids, pellets can be formed. So how these pellets are formed? We take 0.5 to 1 mg solid sample and approximately 100 mg of dry potassium bromide or any other alkyl halide. Why we take alkyl halide? Because it is transparent throughout the IR region. So we grind it and then mix it. The size of the sample should be less than 2 micrometer. We grind it into a fine powder. So why the particle size should be less? So that to avoid scattering of the radiation. So in a case the sample is wet, we use silver chloride windows because in alkali halides, water can, for example, sodium chloride, water can dissolve it. So to avoid this to happen, while using wet samples, we use silver chloride windows that are soft, easily scratched, but they are photosensitive. So they'll reduce when comes in contact with light. So after proper grinding of the sample and using pestle and mortar, the sample is put under a hydraulic press and this type of pellet is formed at less than 100 psi. Another method is to prepare a mull. So in mull method, instead of using alkali halide, KBr or NaCl, we use mineral oil or nugol, fluorolube, etc. for thorough mixing and reduction of sample particles to 2 micrometer. And then again we may so how it is done? First we prepare a cell, same. First we will prepare a pellet, disc or cell with the transparent matrix only. Two cells are, so two transparent cells are formed and then the mull, sample mull is spread on one cell and the other cell is put on it. And then again it will be fixed with the help of hydraulic press and the sample spectra is obtained. Nugol also shows sample bands at 2924, 101462, 1371 centimeter inverse. For sampling of liquids, special types of liquid cells are used. As I have already discussed that AgCl is used, apart from it BAF2, or KRS-5 is used for the preparation for the sampling of liquids. So the sample must be dissolved in a solvent that is transparent throughout the IR region. So there is no solvent that is transparent throughout the IR region. So we have selected two solvents that are used nowadays: carbon tetrachloride, which is transparent within the region of 4000 to 1330, and carbon disulfide, which is transparent in the region 1330 to 625. But both these solvents are toxic and should be handled carefully. So these are the conventional popular solvents. Now we are using less toxic solvents that are tetrachloroethylene or methylene chloride, or N-heptane for the sampling. So water and alcohols are not used for sampling purpose because they absorb strongly in the mid-IR region, as well as they react with alkali metal halides that are commonly used to prepare the pellets, or these are the cell windows. Sampling of gases. So for gaseous samples or low boiling liquids, special type of IR gas cells are used, in which there are two IR inactive windows on both the ends, and these are the knobs to fit in the pressure pipe from which the gaseous sample will enter the cell. The pressure of the gas should be 50 torr in a 10 centimeter cell. The path length is basically increased to obtain a satisfying spectra. Now, accessory techniques to analyze highly absorbing samples are attenuated total reflectance, or ATR technique, is used for thick or highly absorbing solid or liquid materials, for example, powders, threads, adhesives, polymers, etc. ATR requires no sample preparation. In ATR, we use a transparent crystal of high refractive index such as diamond. You must have heard about it, that the cuts in the diamond, the radiation will pass through different directions, so that it will the appearance would be more shiny. So what is happening? The electromagnetic radiation penetrates the sample to a depth, and it undergoes total internal reflection. So during each reflection, the radiation will pass through the sample, so that a satisfying spectra is obtained. The next technique is diffuse reflectance technique, in which samples with rough surfaces can be analyzed: coal, cloth, etc. It depends on diffuse reflection. So what is diffuse reflection? So there are basically two types of reflection: specular and diffuse. In specular, the incidence angle is equal to the reflection angle, but in diffuse reflection, depending upon the roughness, or the for each ray, the angle of incidence and the angle of reflection is different. Unlike specular reflection, where the angle of incidence and the angle of reflection is same for all the rays. Here you can see that for say for example, this ray, this is the incidence ray and this is the reflective ray. So these scattering radiations are collected, and then the spectra is obtained depending upon the concentration of the material by applying a scattering factor using Kubilka and Munk format. When this technique is used along with FTIR, it is known as diffuse reflectance infrared Fourier transform spectroscopy, or drifts. The third technique for the sampling of highly absorbing samples are photoacoustic spectroscopy, which is used for polymer pellets, viscous glues, single crystals, single fibers, etc. In this technique, sample is put under IR transparent gaseous medium, for example helium. So when IR radiation falls on the sample, it leads to the change in the thermal energy of the sample, and due to the heat exerting from the surface of the sample, there is expansion of these gases. So the expansion of IR transparent gas, here it is helium, is recorded, and then the IR spectrum is obtained. General properties and range of IR materials, basically the sampling materials, are listed in this table. For example, for NaCl, KCl, barium fluoride, silver chloride, etc. You may go through the references. These are the references. Thank you.